Everyone. For today's lesson, we are going to learn how to classify quadrilaterals using coordinate proofs. So what's going to happen this time is I am going to give you guys a set of ordered pairs, but I am not going to tell you what shape it is. Instead, we will have the responsibility of deciding what shape we have based on our analysis of the distance formula and the slope formula. So the expectation is that you are going to find all of the sides lengths and you are going to find the slope of all of the sides. And remember, I've taught you some strategies of really working with the opposite sides and looking at the slopes of the opposite sides. And then from there, we can draw conclusions. So what I have in this table is basically it's a cheat sheet. It says, if we have ourselves, if what we see after we've done our analysis is we see that we have two pairs of opposite sides have the same length, meaning like all of the sides do not have the same length, but just simply opposite sides have the same length. And, so the keyword here is and. We notice that we have two pairs of opposite sides have the same slope, but those slopes are not opposite reciprocal slopes, indicating that we don't have right angles. Then what we have is a parallelogram. For a rectangle, if you notice that the opposite sides have the same length, and after analyzing the slopes, you notice that you have two pairs of opposite sides that have the same slope, and those slopes are opposite reciprocal slopes, then that means that we have four right angles and we have ourselves a rectangle. So notice that in terms of the distance, we can break it down into, if we just notice that the opposite sides have the same length, then it's either a parallelogram or it's a rectangle, and the deciding factor is going to be the analysis of the slopes. Do you have opposite reciprocal slopes or don't you? If you do, then it's a rectangle. If you don't, then it's a parallelogram. The same thing is true for rhombus and square. With the rhombus and squares, both of them have the same length. What you'll see is that all four sides will have the same length. That is true for a rhombus and a square. But if you notice after analyzing the slopes that you don't have opposite reciprocal slopes, then that means that you don't have four right angles, and therefore your shape is a rhombus. But if you notice that all four sides have the same length, and after analyzing the slopes, you notice that the opposite sides have the same slope, but you notice that all of the slopes, when you're all putting them together, you end up with opposite reciprocal slopes, then that indicates that you have four right angles, and therefore you have a square. So the nice thing about doing the distance formula first is that it helps you to break it down into two different categories. You're either working with parallelograms and rectangles, or you're working with rhombuses or squares, with the slope formula being your tiebreaker. So let's go ahead and get started with our first example. In our first example, we are always going to be working with just two formulas, the slope formula and the distance formula. Just two formulas. I'm telling you that this is a quadrilateral, but you have to be careful because it's not going to be super easy to identify. What we have here in the grid is we have one scale's going by twos and the other scale's going by ones. So I'm going to write that. This is going by ones and this is going by twos. And so even though it'll be graphed, it's going to be kind of challenging to decide what shape you actually have because it's going to be in disguise. The grid has been what I call warped. So you want to be careful with the scale. So what I'm writing down right here is you have to be very careful with the scale. because you'll notice that all of a sudden, you're not going to be able to tell what shape it is. And if you're going by ones, you might not be able to plot all of the points either. So I'm going to go ahead and plot the points for J, K, L, and M, and I'm going to put them right here on the grid. So I'm going to plot -4, 2. So this is -2, -4, up to 1, 2. And that is J. Then I have -2, 8. So here's -2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to label that K. And I'm going to use my straight edge by the very end. So you might want to have a ruler or the side of a calculator, a book, anything to help you with connecting the points. Now I have 10, 4. That's 2, 4, 6, 8, 10, up 4. 1, 2, 3, 4. This is L. And then M is 2, 4, 6, 8, -2. 1, 2. All right, so here's our shape. And now what we want to do is we want to decide what shape does this actually is this shape. So far it just kind of looks like a parallelogram, but remember that the scale is off and it's not going by ones or not going by the same exact scale each time, so it's in disguise. So what we need to do is we need to analyze the distances and the slopes. So let's go ahead and talk about the distances. And I think that it's helpful to kind of like use color. So I'm going to start with JM. It's also very important to keep yourself neat and organized as you are going through these problems as well, because there's going to be a lot of work that you're going to put in this space. So here is the work for finding all of the distances for JM. So I'm just going to be using the ordered pairs that's given. And if it helps you to write x2, y2, x1, y1, you're welcome to do that. If it doesn't help you, then don't write it. So I'm working with J and M, and I'm going to write 8 minus -4, please be careful with your signs, squared, plus -2 minus 2, squared. So negative makes a positive. That's going to be 12. 12 squared is 144. And then -2 minus 2, that's -4. -4 squared is 16. So now I have 144 plus 16, and that is going to be the square root of 160. This can be simplified into 16 times 10, the square root of 16 times 10, which is 4 square roots of 10. So now I'm going to find the side length for ML. And honestly, it does not matter what order you end up going with. So I'm going to just work with ML. And we have for ML 8 minus 10 squared plus -2 minus 4 squared. So 8 minus 10 is -2. -2 squared is 4. Plus -2 minus 4, that is -6. -6 squared is 60. So excuse me, -6 squared is 36. And 4 plus 36, that is 40. Square root of 40 is 4 times 10. So this is 2 square roots of 10. So the side lengths are different. That's what I see so far. So now let's go ahead and find the length of LK or KL. And when I find that distance, I have 10 minus -2 squared plus 4 minus 8 squared. So this is equal to the square root of 10 plus 2, which is 12. 12 squared is 144, plus 4 minus 8, which is -4, -4 squared, which is 16. So I end up with the square root of 160, and I already simplified that to 4 square roots of 10. So now I need to find my last side length, which is JK. So with JK, I have -2 minus -4 squared plus 8 minus 2 squared. Negative negative makes a positive. -2 plus 4 is 2. 2 squared is 4. 8 minus 2 is 6. 6 squared is 36. This is the square root of 40, which we know is 2 square roots of 10. So what we notice here is that we have opposite sides that are congruent to each other. So I notice that we have 4 square roots of 10, 4 square roots of 10, and I see 2 square roots of 10 and 2 square roots of 10. So we have opposite sides that are congruent to each other, which tells me that this is either a parallelogram or a rectangle. So now I need to look at their slopes. And I ran out of space, so I'm going to put my space for slopes down here. So I'm going to draw a line just so that I have room for my conclusion statement. And I'm going to find all of the slopes going all the way around, starting with JM. So I need to find the slope of J to M. So remember that the slope formula is x2 or y2 minus y1 over x2 minus x1. So some of you might be noticing that I'm not writing down the formulas, and there's a reason for that. They're telling us to use the formulas. So this is not like a coordinate proof per se. You're just, well, it is a coordinate proof, but what I mean by that is they're telling us which formulas we need to use, so we don't have to write them out. Versus before, when they're asking us to prove properties, we have to make a decision as to what formula to use. So because they're not forcing us to make that decision, you do not have to write down the formula to use. All right, so let's go ahead and find the slope of JM algebraically. So that is going to be -2 minus 2 divided by 8 minus -4. So this is going to be -4 over 12, and that is simplifies to -1/3. So now I'm going to identify the slope of my next segment, which is ML. So I'm just going in the same order that I did up here. And that is equal to -2 minus 4 divided by 8 minus 10. So this is -6 over -2, which is equal to +3. Oh, interesting. I'm going to write down that this is 3 over 1. Next, let me go ahead and find the slope of KL. So the slope of KL, that is 4 minus 8 divided by 10 minus -2. So 4 minus 8, that is -4 divided by 10 plus 2, which is 12, and that simplifies to -1/3. And finally, we have the slope of JK. And the slope of JK, that is 8 minus 2 divided by -2 minus -4. So that is 6 divided by negative makes a positive, 6 over 2, which is 3. And I'm going to write that as 3 over 1. And the reason I'm writing that as 3 over 1 is so that I can analyze my slopes. And what I see here is that opposite sides have the same slope. And now I just need to decide, are these slopes opposite reciprocals? So let's remind ourselves of what opposite reciprocals are. Opposite means that they have different signs. And we certainly have different signs here, 3 and -1/3. And now we have to talk about, are these reciprocals? So did the fraction flip? 3 over 1, 1 over 3. 3 over 1, 1 over 3. So yes, I'm going to say that 3 and -1/3 are opposite reciprocals. So what does opposite reciprocals mean? Well, it means that the intersection of these two segments or these two sides will form a right angle technically, this is a right angle. Perpendicular lines form right angles, even though it doesn't look like it. So if you see that you have two pairs of opposite sides that are congruent, which we decided that this was either a parallelogram or a rectangle, and you have opposite reciprocal slopes, indicating that you have four right angles, we can classify this as a rectangle. So therefore, quadrilateral JKLM is a rectangle because we noticed that opposite sides were congruent. So JM was congruent to KL, and ML is congruent to JK, and segment JM is going to be perpendicular to ML. JM is perpendicular to JK. Excuse me, I think I did that wrong. So JM is perpendicular to JK. JM is perpendicular to ML, so they did that correctly. And then finally, we have JK is perpendicular to KL. And we have KL is perpendicular to ML. So I'm just going all the way around the shape and I'm identifying what it's perpendicular to. And that is what we can conclude. So we're just identifying what we noticed. If you want to write it out in words, you would say that opposite sides are congruent and consecutive sides are perpendicular, indicating that there are four right angles. So you can write that out as well, and maybe I'll do that in the next example. All right, let's go ahead and move on to our next example, letter B. For letter B, we have WXYZ is our quadrilateral, and we're going to go ahead and plot these points. So we have W being located at 0, -3. We have X at 5, 3. Y at 8, -1. And Z is at 3, -1. And now that I'm looking at it, I think that I put in a typo because I'm looking at this and this is not working out very well. So let me go ahead and change this 0, -3 to a 0, +3. And I think that it will actually work out. So let me change this to a 0, +3. I think I just had a typo in there, guys. I'm sorry about that. Now that makes more sense looking at this picture. All right, so let me go ahead and, so this is a W, X, Y, and here is Z. All right, so now that I have this, we can probably assume what the shape is going to be, but we still need to prove what our assumptions are. So we need to say, what do we have here? So let's go ahead and start off by identifying our distances. So I'm going to find the distance of WX first. And remember that we're talking about this distance right here. So WX, I have 5 - 0 squared plus 3 - 3 squared. 5 - 0 is 5. 5 squared is 25. Square root of 25 is 5. Next, I'm going to find the side length of XY. XY, that is going to be 8 - 5 squared plus -1 - 3 squared. So that is equal to the square root of 8 minus 5, which is 3, 3 squared, which is 9, plus negative 1 minus 3 is negative 4. Negative 4 squared is 16. And 9 plus 16 is 25, and the square root of 25 is 5. Ooh, so far I have consecutive sides that are congruent. And now I need to find the segment of, or the length of zy or yz. All right, so let's go ahead and find yz. So that is 3 minus 8 squared plus negative 1 minus negative 1 squared. So negative makes a positive. I have 3 minus 8, which is negative 5. Negative 5 squared, which is 25. Negative 1 plus 1 is 0, so there's nothing more to write down. The square root of 25 is 5. So far I'm leaning towards this being either a rhombus or a square, so it just depends on what we have. And I have my last side that I need to find, which is WZ. And WZ's distance, that is going to be 3 minus 0 squared plus negative 1 minus 3 squared. So that is 3 minus 0, which is 3. 3 squared, which is 9. Negative 1 minus 3 is negative 4. Negative 4 squared is 16. This is the square root of 25, which is 5 once again. So far, I can see that all of my side lengths are the same. And that tells me that I am dealing with either a square or a rhombus. That's what I need to decide. Is this a square or is this a rhombus? So now I'm going to identify my slopes. So let's go ahead and find the slope of WX. So I'm starting at the very beginning again. And here's like a little trick. Here's your y2 minus y1 and your x2 minus x1. It's a trick. You can go 3 minus 3 over 5 minus 0 instead of going back and analyzing the ordered pairs. For some people, it's a shortcut. But this is 0 over 5, which is 0. So now I'm going to identify the slope of xy. So let me just keep myself straight. So this was wx's slope, and now I'm on xy's slope. And all I did was just mark it up with a new color just to kind of keep myself organized. So this is going to be negative 1 minus 3 over 8 minus 5. So that is negative 4 over 3. And I think I did that one correctly. Okay, so now let's go ahead and move on to YZ. So the slope of YZ, that is equal to negative 1 minus negative 1 divided by 3 minus 8. Negative makes a positive, and we end up with 0 over negative 5, which is 0. And finally, we need to find the slope of WZ. And our slope of WZ, that is negative 1 minus 3 divided by 3 minus 0. So that is negative 4 over 3. So now let's look at our slopes. I see a 0 and a negative 4/3. And we know that the only way for us to have perpendicular lines with 0 is if we had an undefined slope. And the opposite reciprocal for negative 4/3 would have been positive 3/4. So therefore, in this problem, I'm going to say that 0 and negative 4/3 are not opposite reciprocals. And since they are not opposite reciprocals, we do not have 4 right angles. And therefore, it is not a square this time. We have ourselves a rhombus. So quadrilateral WXYZ is a rhombus. And it is a rhombus because there are 4 congruent sides, or simply all sides are congruent, and there are no right angles. no opposite reciprocal slopes. So any conclusion that kind of like explains what you saw is perfectly fine. So before, when I wrote out my statement, I used symbols. This is one approach for your explanation. You can use symbolically explain what you saw. Another way is to use words. I noticed that all four sides were congruent, and since we do not have opposite reciprocal slopes, there are no right angles. Therefore, we have a rhombus. So there's choice in how you want to write out your explanation. The last example is letter C, and I would like you guys to please complete this one on your own and be ready to discuss it the next time that I see you. That is the end of today's lesson. If you have any questions over anything I talked about, please feel free to email me. Otherwise, I hope you have a wonderful day.